Hello, my name is Reynolds. Welcome to Mat-073. Today we're getting our third section in Chapter 4, and we're looking at factoring techniques. And the first thing you always want to kind of think about when you factor is the greatest common factor, the GCF. And you want to factor out the greatest common factor because it makes factoring a little bit easier. So always look for that first. We'll also look at factor by groupings, and then the next video will be how to factor trinomials. With three terms. But for today we're looking at greatest common factor. So what you want to do is look for a number or a variable that can be divided evenly by both. And sometimes we can divide both sides by a negative number as well. So if you think about this -2 being the common factor because each term divides through by -2, and then what's left goes inside. So 18 divided by -2 gives me the -9. Later on we're going to learn that this is called the difference of two squares. That's not in this video, that's in a separate video as well. But I wanted to show you there's many techniques of factoring. Here's only two of them. One of the things that we're going to kind of explore today though is when given four terms you might want to consider factor by grouping. And that means just let's look at the first two terms and group those together and pull out the GCF, which is really the topic of today, looking for greatest common factor. So if you divide each term by 3x and tell me what's left, well, 3x squared divided by 3x is x, and 12x divided by 3x is just the 4, but you hang on to it. You don't throw that 3x away. So that's the GCF. And over here, the greatest common factor would be maybe -5. You could pull out a 5, but let's pull out a -5, so that way I can get this to be a common factor as well, and then pull out the x minus 4. And what I mean by pull out is you're literally dividing each term by x minus 4. So it looks like it's canceling, but you don't throw it away. You hang on to it. So let me show you some examples of this. A factor, to factor a polynomial, you express it as a product. So when I say the word factor, you're looking for multiplication. And so we've talked about polynomials in a previous lesson. So when factoring a polynomial, we look for common factors such as, again, 5x, and then you think about dividing each term by that GCF. So if the greatest common factor, which oftentimes is difficult to pick out, because you can pick out a factor or a common factor, but make sure it's the greatest common factor, and then think about dividing each term by that, and then telling me what's left. So this 5x squared divided by 5x gives me the x term, and then 15x divided by 5 gives you the 3. So again, an example here, coming up with a common factor, I'm looking at the 9 and the 27, and it looks like I can divide each term by 9. So I'm going to factor out a 9, and then I don't have to write this, but this is what I'm literally thinking. 9m squared divided by 9 is m squared, and 27 divided by 9 is 3. And then again, I always want to see if I could factor some more. So it's implied whenever it says factor, to factor completely. And I can't factor anymore. So this is not the difference of two squares, which again we'll talk about in another video. So we're actually done right here at this stage when the author agrees. So let's look at this again, a little bit more difficult. Let's start with the numbers. 25, 35, and 5. It looks like maybe 5 is a common factor. Between x squared, x to the 6th, and x cubed, it seems like each group or each term at least has two x's in it. So I'll say that that's what's common to the three groups. And then the y value, if you haven't already figured it out, it's always the smallest exponent. So I'm going to pull out y cubed in here as well. So thinking about dividing each term by the greatest common factor, I'll write it here. Again, many of you can do that in your head, but if I write it out like this, then it makes it a little bit easier to see what's left. So I'm canceling the x squareds, and then y to the 5th divided by y cubed is y squared, plus 7. Remember, when you do x to the 6th divided by x squared, you don't divide those. It's actually a subtraction property, and you get x to the 4th. And the y cubes will cancel. And over here, -15 divided by 5 is -3. I have an x in the numerator and a y. So that's the greatest common factor technique. Sometimes if you cannot factor something, it's called prime. So if you had something like 3x minus 5, there is no common factor, and so that's called just a prime polynomial. It's factored already completely, so there's nothing that you can be done. Sometimes the author may ask you to pull out a negative. So here the common factor could be 4, but you could also pull out a negative 4. And then I noticed that I've got some variables that are common too. I'm going to pull out one of the x's. So I'm thinking about pulling out a negative 4x. And again, I'll write that up here. And then looking at what's left, negative divided by negative is positive. The 4's cancel, and I'm left with an x value. And over here, negative divided by negative is positive. 16 divided by 4 is 4, and the x's cancel. It's easy to check these because all you have to do is distribute, which was a previous video as well, and just multiply these back together and see if you get back to the original problem. Whoops, that's not squared. It's just to the first power. So that looks like, again, the original. So I'm pretty content with this being the final solution. It looks like the author, once again, agrees. So now we're going to talk about how to group. So sometimes when you're given more than 3 terms, 4 terms or more, sometimes we want to try to group together. So before we look at the grouping technique, looking at what's common here, before we talked about numbers being common or even variables, well, here is an example where we have a whole factor that's common. So I'm going to factor out the common factor, which is x minus 4. So I'll highlight it here in pink. If I literally think about dividing each term by that pink, x plus 4, remember terms are separated by addition and subtraction. All of this is canceling, leaving me with the m and then plus the y minus b. And you can put that y minus b in parentheses, or you could drop it. It's just a grouping mechanism. It doesn't mean to multiply. So I would probably just leave the final answer. And again, it looks like the author kind of agrees. So again, given 4 terms, we want to try to look at the first 2 terms grouping together first. We could reorganize this. We don't have to put the first 2 terms together, but I would start with the first 2 terms and look for a GCF, in this case, which is y cubed, leaving you with a y squared plus 5. And then I like to write down that y squared plus 5 again, because if you can't get another y squared plus 5, then we cannot factor by grouping in this method. I'm going to put a blank out here and think about what goes in this blank times the first term to give me the third term, which is 3y squared. It looks like a 3 does, and then I'll check it. Does 3 times the 5 give me the positive 15? And if so, then I factored this correctly. I'm going to pull out now, again, this pink term, which is y squared plus 5. And literally that gets divided by each, y squared plus 5. And I cancel, and what's remaining is y cubed. I think there's a plus sign right in here. Plus 3. And then I look, can I factor some more? And I don't think the answer is yes. By the way, if you don't put parentheses in here, then this is actually incorrect, because the way that the statement looks right now, it looks like only the 5 is being distributed. So you must put parentheses around the factor that you're factoring out. All right, so there's how the author chose to explain it. So let's try this again. Factoring the first 2 terms together, it looks like a 3 is common. So if I divide each term by 3, I'm left with x minus y. I'll immediately write down another x minus y and think about what number can I put into this spot so that when I multiply by x, I'll get this third term, which is negative ax. It looks like a negative a works well, but let's check it. Does negative a times the negative y also give me the last term, which is positive ay? And the answer is yes. So my common factor this time is x minus y. And again, I'm going to put parentheses around that x minus y, so I know that that whole factor is being multiplied by what's remaining. And what's remaining is everything that's not in pink. So if I factor out the pink, I'm left with 3 minus a. Last one, let's try to factor this one by grouping. And I'll put the first 2 terms together, which is x squared, leaving me with an x plus 2. I'll immediately write down another x plus 2. And then I ask myself, well, what goes in here to multiply by x to give me the third term, which is a positive 2. But wait a minute, we have a conflict here because the positive 2 times the positive 2 gives me a positive 4. And I don't have a positive 4, I actually have a negative 4. So I cannot factor out this x minus 2 because this actually doesn't work. So either I did something wrong, or I can try to reorganize these, is one of the techniques. So I could try like putting the x cubed plus 2x squared minus 4 together, and maybe factor out an x here, leaving me with x squared plus 2, but there's no way to get another x squared plus 2 over here. The only common factor here was a 2, and that's not going to work. So I could try reorganize these things, but at the end of the day, I don't think anything can be factored. So here's an example where you have 4 terms. It looks like we can factor by grouping, but we simply cannot. So you just end up saying it's completely factored, or sometimes we write the word prime. I hope this video was helpful. If you have any questions, feel free to email me. Thanks.